Channel. Now here in this video, I want to talk about partial fraction decomposition. So I put it down as PFD. Okay, PFD, not PDF, right? Okay, so by partial fraction decomposition, I'm going to say that if we have a whole fraction, okay, we can decompose it into other small fractions such that the sum of those small fractions would add up to give us the original fraction. So we call that partial fraction decomposition. That is to say, when we have, for example, 1/2, okay, this is equal to, we can write this in different ways. Okay, we can decide to put it down as, let's say, 1/8 plus 1/8 plus 1/4. So the sum of these fractions, if you want to take them out, these fractions will add up to 1/2. So that means that 1/2 can be decomposed into its partial fractions, alright, so that the sum of these fractions will give us 1/2, alright? Okay, so this is just a rational number, so a real number. Now, when we'll be doing this, we'll be dealing with polynomials, alright? We'll be doing the partial fraction decomposition. So I'm just using this to explain to you guys the concept actually, what it actually means, okay? We can write this 1/2 as many sums as possible. I can decide to use 1/16, and I'm going to add it as many times. Let's say I'm going to add it like 8 of them, 8 places. So 16, 1/16 plus 1/16 up to 8 will give us 1/2, and something like that. We can decide to decompose 1/8 into different fractions, okay, so that their sum will add up to that. So these are the decomposition of this, right? Okay, so that is just that. So let me give you guys a little thing to see. If f is a polynomial of degree n, okay, and g, okay, let me put it this way. Let me put x, alright, so it's in terms of x, and then g of x is a polynomial, alright, of degree m such that m is greater than n, then we're going to say that f of x divided by g of x can be rewritten as some fractions, right? This here is called a rational function, which is made up of polynomial function and a polynomial function, just like that. So I'm saying that if it's a polynomial of degree n and g is a polynomial of degree m, so when we talk about degree of a polynomial, we mean, let me just use this. If you have x squared plus 2x, okay, so the highest power here is 2. So that is the degree of the polynomial, and this is called a quadratic polynomial or a quadratic function. Choose to put it that way. Okay, or a quadratic expression. I just cleaned it. But if that is the case, and I'm saying that m, the degree of this denominator, that is g, is greater than the degree of the numerator, okay, so this can be called a partial fraction. Sorry, a proper fraction, not a partial fraction. This is called a proper fraction. Just when you have a normal proper fraction in terms of numbers, if the numerator is smaller than the denominator, then that is proper fraction, right? Then improper is a case where the numerator is bigger than the denominator, so it's improper, like that. Okay, now here we are also going to consider a case where the degree of the top and the degree of the bottom are the same, but that's not for now. Okay, so when we have this, this fraction here can be decomposed into some other fractions, all right? Let's put it as, let's say s of x divided by t of x plus u of x divided by v of x plus and so on and so on and so on. Okay, where where the degree of this man here, okay, is greater than the degree of this other man on top by 1. So I'm saying that we can have if we have a rational function where the top and the bottom are just polynomials, okay, and it is a proper fraction, not partial fraction in this case. Then you can decompose it into its partial fractions, right? S of x, that is a polynomial, divided by t of x plus u of x divided by v of x. Now, where the degree of the bottom here is greater than the degree of the top here, so you can decompose it into other proper fractions. This is also the case for this one. So where the degree of the bottom here is greater than the degree of the top here by 1. The degree greater than this by 1 means that if t of x is x squared plus 2, okay, that is degree of t of x is equal to 2, right? Okay, and okay, it means that now for the degree of t of x to be greater than the degree of s of x by 1, it means that the s of x should be, the degree should not be 2, it should be less than t of x by 1. That is to say, it should be 1, alright? So that means we're talking about x plus something, okay, let's say plus anything. But provided, if this is to power 2, then this one is to power 1. If this is to power 1, that is a linear function, then this is going to be to power 0. That is just going to be a constant function, right? And something like that. So if this is to power 3, this one should be to power 2. Okay, it does not really matter the particular function it is, but it only matters the general something. In fact, let me put it down as, if this is ax squared plus bx plus c, that is a quadratic function, then this should just be x, or let me use ex plus a, right? So this should be linear. If this is cubic, that is to power 3, then this should be a quadratic, okay? So that is the same thing for this other one and others, if at all there will be more than this. Okay, so this is just a general approach to it, right? And then other conditions we'll talk about it in the next series. Okay, so we just started the partial fraction, and you're welcome to my channel. This is Substance channel. Please, I want you to subscribe to my channel and turn on notifications as we post other videos related to these partial fraction decompositions, examples. Okay, we talk about different factors we can have in the denominator. Yes, I forgot to add something. Now, this is equal to this, where t of x, v of x, and so on are factors of g of x. This is very, very important. Okay, so this is very, very important because I'm saying this will be equal to this, okay? Now, these denominators here are going to be the factors, all right, of the g of x. That is, from this fraction, we decompose it, okay? So the denominators, each of these denominators are factors of this bigger polynomial on the denominator of the left-hand side. So we are given that if the denominators of the right-hand side, in fact, when we decompose it, we will get the factors of this and we will write it in this form. You will just see that, okay? But take note of this. This is very, very important. All right, so let's move over to some examples, okay, under different categories of rational functions we're going to be seeing.